Hey everyone, welcome to Coding Simplified, and today we'll see a new problem in DP. So basically our aim is to identify the minimum number of jumps to reach the nth stair. It means we have a staircase and we need to reach a particular step. Now our possible steps are that either I can take one step or two steps or three steps, right? It means we need to find the minimum jumps. Then we can reach the nth stair. So for example, let's say if I am at here, this is my base, and now I need to go to fifth stair. So this is third stair, fourth stair, and fifth stair. It means I need to reach till here. Now I can directly make either one jump, or I can make two jump, or I can make three jump, right? Because these are the possible steps. So I need to find out in how many jumps I can reach till nth stair. So like in this case, how many minimum jumps I have so that I can reach in fifth stair. So this is very important point, that I need to find the minimum jumps, not the total ways, because in last tutorial we saw that how many total ways through which we can reach the nth stair, but here we are finding out the minimum steps or minimum jumps, then we can reach the nth stair, right? So like if you say in this case, because we have three, so first of all we'll take three step. So after taking three step, we'll reach here. So this is first jump. Then I will take two step directly. It means the number of ways are in the minimum jumps is 2. In 2 jump I can reach to this fifth stair, right? So that's all I need to find out. So now let's consider a basic case. Let's say if I need to reach the nth stair. So I need to reach the nth stair. It means if this is a stair, then there are several stairs, right? And here I will have base. So now you see that I can take one step, two step, or three step. It means, let's say I can reach here, or I may here, or I can be here. Now from this place, if I am at here, then I can take directly three step and I can reach here. Now if I am here, then also I can take directly two step and I can reach here. And if I am here, then I can also take one step and I can reach here. So if I know in how many jumps I have reached there, then I will add simply one jump into it, right? So I can simply add 1 plus whatever the jump is. Similarly, if I know the minimum jumps to reach here, then I can simply add plus 1, because in one jump I can reach here. Similarly, if I know that in how many minimum jumps I have reached here, then I can add simply 1, because if I take 3 steps, then in one jump I can reach here, right? So it means that if I know the minimum of all these jumps, the whatever the minimum jumps it has taken to reach here, to reach here, to reach here, so whatever the minimum jumps it has taken to reach here, then I can simply add plus 1. So it means if I know the minimum jumps to reach till n minus 1, or till n minus 2, or till n minus 3. So if I know that what is the minimum jumps out of these three, so I can add simply 1, right? So this is the answer. This will be the answer of my question, right? That if I know that what is the minimum jumps it has taken either to reach here or to reach here, then I will find out the minimum jump and then I can add simply 1, right? So t minus 1 says that how many jumps it has taken to reach till the previous step. N minus 2 says what it has taken to previous n minus 2 steps till here, and n minus 3 means how many jumps it has taken to reach till this position. Because if I know the minimum jumps of this one, then I can add simply 1, because I can jump 1, 2 steps or 3 steps, right? So now let's take example of the n5 again. So if I have this n5, right, it means I need to find out that how many times or how many minimum jumps it will take to reach till fifth stair. It means if I know the how much time it will take to take the fourth stair, to third stair, and to take two stair. So whatever will be the minimum out of these, I will add 1 plus among this one, right? Now again I don't know about T4, so again I will recursively go here and I will say again that what it will take for T3, T2 and T1. Right? Now what I can do, that I can have some base conditions. So I know that if I want, let's say this is my base, and if I want to reach only this position, let's say if my n equals to 0, it means minimum jumps to reach 0th stair. So if it is 0, it means I need not to go anywhere, right? So I can have this base condition that if n equals to 0, it means return 0, because minimum jump is 0, right? Now let's say minimum jumps to reach first stair. Let's say if my n is 1. So if you need to go only one stair, then you can take in one jump, right? Because I can directly go in one. Again, if your n is 2, let's say if your n is 2, then again I can take 2 steps. It means in one jump I can reach here. Now if your n is 3, then again you can take one stair, right? So this will be my second condition. This will be my second base condition, that if your n is 1, or if your n is 2, or if your n is 3, then return 1, because in all cases in one jump I can directly reach here, right? And if it is not the case, so what you do, you basically return 1 plus minimum of n minus 1. So basically let's say if it is my function, so this will be my recursive function, and let's say my function is minimum steps, where I am passing the int n, right? So this is my function, recursive function. So I will say the minimum steps of n minus 1, of minimum steps of n minus 2, and minimum steps of let me write here, minimum steps of n minus 3, right? It means this is the thing, that if it is, if base conditions are not matching, then you just get the minimum of the tn minus 1, tn minus 2, tn minus 3. So this is what we are doing, that we are saying that if you don't have this T5, it means whatever the minimum of the T4, T3 and T2, right? Then again I don't know about T4 because this is not base condition. Then again I go that whatever the minimum of this one, then I can add 1 plus into minimum of this one. Now from the base condition I know that if it is a 3, then it will return 1, that I can directly jump to third step in one jump. For T2 also I can directly go in one jump. For T1 also I can directly go in one jump, right? So it means for T4 we will store the 2, because the minimum of this T3, T2 and T1 is 1, and minimum of all this means 1. It means 1 plus 1, 2. So T2 have 1. It means if you want to go to T4, then you need 2 steps. Now T3, for T3 we know that it will have 1, and for T2 also it will have 1. It means it will check the 1 plus minimum of 2, 1, 1. So the minimum of this is 1. It means it will, so for T5 it will say 2. It means in 2 steps I can reach till 5th stair, right? So 1 step I will take to T3, and 1 step I will take again to T3 to T5. So now here it comes the important point, that in this problem can I apply the dynamic programming or dynamic programming technique, right? And DP, and we can apply DP here if it follows the 2 property. So first property is that it should be the overlapping subproblems. Overlapping subproblems. Now overlapping subproblem says that if you are finding out the subproblems again and again, then that is overlapping. Like in this case, let's say if it was my T6. So in T6 what will happen? You will find T5, T4 and T3, right? Now again when you will go to T4, you will find T4, T3 and T2. Similarly for T4 you will find T3, T2 and T1, right? So now what you are doing, what you are seeing here, that basically we have so many subproblems. This T4 we are finding out 2 times, right? Here also we'll find out, and here also we'll find out. Similarly this T3 will also be finding out many times, right? Now this is just we have n equals to less number, like we have only 5 or 6. But let's say if your n is 20 or 25 or 13, big number, then there will be so many subproblems. You will finding out the one thing again and again, right? And as you can see here that it's a recursive call. It means you will finding out the complete portion altogether again, right? So it means it is following the first property of the DP, that there is overlapping subproblems. We are finding out one thing again and again, so we can apply DP here. Now the second thing is says that is it following the property of optimal substructure. So optimal substructure property says that can you achieve your final solution if you have the solution of the subproblems, right? So yes, we can do, like you can see from here, that if I know the minimum jumps to reach till here or till here or till here, then I will get the minimum out of this and I will add 1 plus, right? It means I can find the final solution if I have the subproblem solutions. So this is again following the second property, that yes, we have the optimal substructure property here. So basically in DP what we do, that rather than recursively going or rather than just returning the value, we basically store the value, right? And using those values, using the storage value, then we can calculate the further value. So this is what the DP says. So in this case we can say yes, it is following the both property. It means I can apply the DP here. Now DP can be applied in two ways. One is top to down approach and one is bottom to up approach. So in top to down DP approach, what we say that whenever you are finding out any value, then before returning you also store that value in a storage, right? So what will happen, like in this case, whenever I will finding out the value of T3, so I will store this value and then I will return. So what will happen, that when this will again ask, so when this T4 will again ask, then we need not to calculate this again. We'll just check that whether this value is already present. If this value is already present, it means we have found out the value, and then you can simply return from here. Then in this case we need not to calculate all this portion again, right? So this is the point of top to down. And why we say top to down? Because we start from the top and then we keep on going to till bottom, right? So in top down approach, basically we take the help of the recursive approach as usual. So this is my recursive solution. So basically I just change the recursive solution a little bit and then I calculate and then I store the value. So in this what you do, that whatever your n is, you basically initialize a array of the n plus 1 values, right? So let's say this is 0, 1, 2, 3, 4, 5 and here we have 6. So let's say if I want to finding out if my n is 6, means minimum jumps to reach 6th stair. So at the starting I will initialize all values to 0. Now this is a point because I am initializing the value with 0. So through 0 I can check that if my value is 0, it means I haven't inserted the value yet, or I haven't found out the value yet. And if your value is not 0, then it means you have found out the value. So basically what I will do here in this function, I will take another function minimum steps, where I will pass the array, so this array, and where I will pass the int which I want to find out. Now these conditions will remain same, that if n equals to 0, return 0, if n equals to 1, if n equals to 2 or 3, then return 1. Then here you basically change. So what you do, because here you are just returning, but here it will change that if your array size, if your array of n is 0, it means if it is 0, it means we haven't found out the value. Then you basically store the value here, that an of the minimum of again you call the function, same function, the minimum steps n minus 1, minimum steps n minus 2 and minimum steps of n minus 3, right? So once you found out, then you basically store the value here. So what will happen, that after storing the value, so this is my if loop, and then you return the value from here, return an. So basically what will happen, that when we'll start from this T6, it will go to T5, again it will go to T4. So when it will found out this value, this T4, so it will basically store the value here as well. So rather than 0, because we know that for T4 it will calculate 2, right? So what would happen, that when it will go again here, it will check that whether A4 is 0. No, A4 is not 0. It means it will not go in this if, and then it will simply return this an. It means it will simply return this 2. So in this case we would not calculate T4 again, right? So if you see our previous videos as well of the DP, like the same thing we did in the Fibonacci, the same thing we did in the total ways to finding out to reach the nth stair. In top to down approach, what we do, we just take the help of the recursive approach, because in recursive approach we just return, right? You can see here we just return, we don't store the value. But in top to down DP approach says that whenever you are returning the value, before that you store the value as well, so that what will happen, that whenever it will again ask, then you can simply return, right? So that's the basically concept of the top down DP approach, that you store the value and then you return the thing, right? So basically how we have improved the complexity, that if you see in the recursive approach, basically we were doing the 3 recursion all together in parallel, 1 recursion for this one, 1 recursion for this one, and 1 recursion for this one. So earlier my time complexity was 3 raised to power n. Why 3? Because I was doing 3 recursion in parallel. So earlier my complexity was 3 raised to power n, but now my complexity has been improved to big O of n, because for a particular solution I am finding out the value only once, because whenever the same value will ask again, I can simply fetch from the array and then I can return, right? So my complexity has been improved from 3 raised to power n to big O of n. Now if you talk about the space complexity, so earlier because I was using the stack, so my space complexity was big O of n, because in recursion it uses a system stack. But now if you see here I am using the array, so it will be also have the same stack, the same big O of n, because I am using the array, right? So it means through the DP approach we have improved our complexity, the time complexity especially. So now let's see the second approach, which is bottom to up approach. Now in bottom to up DP solution, what we do, like if you sign top to down, what we did, we basically started from the top, and then whenever we found out the value, then we store in the array. So here also we store the value, but it says that if you have the base condition, if you have the base bottom condition, then you can find out the top values, right? So it means it says that if you know the last 3 values, then you will find out the minimum value, and then you will add the 1 plus into this, right? So the same concept it is doing here. It says that if you can find out the n value of the minimum of the tn minus 1, tn minus 2, and tn minus 3. So if you know the minimum of these 3, then you can add plus 1 and then you can find out the value. So it says that initialize the bottom condition. It means to go to 0th stair I need 0 steps, to go to 1 steps I need only 1 jump, to go to 2 steps the second step I need only 1 jump, because the possible steps are 1, 2 and 3, right? So it says that now if you have these 3 conditions, then can I achieve T3? Yes, I can achieve, because I know the last 3 conditions. Then if you have this T3 as well, can you achieve T4? Yes, I can achieve. So same way it says that using this you will keep on going further, and whenever you will want the nth stair, so I know the last 3 values and then I can easily find out, right? So this is the bottom up DP approach. So like in this, what we do, this is my function. I initialize an array with n plus 1 because I start from the 0. Then I initialize the base condition. So these are my 3 base conditions, right? And then I start from I equals to 3 till n, and then I apply simple this thing, that AI means array. So array, in this AI store the 1 plus minimum of these 3 values, and then you keep on going till n, and at the last you simply return an, right? So what I have done, that in this bottom approach I'm basically using the capability of storing, and then I'm from the bottom values I am finding out the top values. So this is why this is bottom up approach. Now if you talk about the time complexity, so if you see that if you want to find out the nth stair, so I will start from the bottom, from the 0 till the n. So my overall complexity will be big O of n. Now if you talk about the space complexity, so because I'm using an array here, so my space complexity will be big O of n, right? So this is my bottom to up DP approach. Now if you see here that we are basically using an array, right? So that is why it is big O of n. But we can basically improve this a little bit. So if you see, to finding out the any value, I need to have only last 3 values, right? And if I'm starting from the start, so can I initialize these values as t0, t1, t2 like a? So this is a variable, b variable, and c variable, right? And so basically here, rather than doing this, you will not initialize this one, and you will initialize three variables. This is a, this is b. So let me write like this. So this will be basically a variable, this will be b variable, this will be c variable, and this is int variables. This is int, this is int, this is int. So I have initialized a with 0, b with 1, c with 1. So what I'm doing, rather than array, I'm just taking three variables, and this for loop will be as it is. And now I will take another variable d, which will basically calculate a, b, and c, right? So this will be minimum of the a plus b, c, and now I will update the value for the further calculation. So it means now my a will initialize to b, b will initialize to c, and c will initialize to d, right? And at the last I can return c. So via this, what happened, that rather than array, we have just taken three variables. So my complexity will improve to big O of 1, because these are constant variables, so it will be big O of 1, right? So this is a slightly better approach of bottom up DP solution, right? So now we have seen different approaches. Let me show you the code as well in a brief. So though it is just that whatever we have covered. So this was the first solution that we covered, that if you want to go to minimum steps, then if your n is 0, then you simply return 0, or if your n is 1, 2, or 3, then you return 1, because I know that I can go to 1 stair, 2 stair, 3 stair. In all the cases it is 1. Else if it is not the case, so I get the minimum of all these. So this is I have done. First of all, I have get the minimum of these two values, the n-1 of n-2. Then again I have taken the minimum of this values, and then n-3, right? So rather than creating a new function, I have just done like this. Similarly, then we saw the top to down approach. So top to down approach was the improvement in the recursion. So here basically we store the value. So we said that this basic condition will be same. Now whenever you are finding the value, then I store the value in this array, right? So this thing remain the same. This is same recursive function, but here basically we are storing the value in this array. So what happens, that whenever it will ask again, we can simply return from this array, right? So this was the top to down approach. Then we saw the bottom up approach. So in bottom approach, we initialize an array, and then we initialize the three base conditions. So this is how we have initialized the value, that if I want to go to 0th stair, 1 stair, or 2nd stair, then I start from the 3, I go till n, and then I keep on adding the values here. It means 1 plus method minimum of this one, and then method minimum of this one, right? And at the last I return the value fn. Then we saw the better approach of this bottom to up. So in this, we basically, rather than array, we just took three variables a, b, c, and then we'll do the same this for loop, and then we'll update the values using this: a equals to b, b equals to c, c equal to d, and then at the last we return c, right? So if you see here that let's say if I want to get to n equals to 5, so if you run the program, these are all the four functions we have started. So if you see, all are returning same value, that I can go to 5th stair in 2 jump. Let's say if I go to 7, and if you run the program, you can see that I can go to 7th stair in 3 minimum jumps. One jump you can take 3, then again 3, then again 1, right? So this is the solution. So that's it guys about this video. We have seen different solutions, and we have seen that why we can apply the DP here, because this problem was following the two properties of DP: overlapping subproblem and optimal substructure, right? So that is why it was very important that we understood first the recursive solution, and then we went for the DP solutions, right? So that's it about it. And if you have any doubts, then please write in the comment section, and I will try to explain that. And I will also put the source code into description, so if you want, then you can also get it from there. And so that's it guys, and if you have liked the video, then please like it and subscribe the channel for more such videos. Thank you.